Hello everyone, today we have a problem in regards to dynamics and it is in physics. So today it's just we're talking about a concept that is pushing and pulling at a certain angle. So if we're having, for example, let's say, if you have a box and you've applied a force to the left, then it is going to move in that direction, assuming that there is no friction. However, if there was friction acting on it, and then your force has to overcome this friction. So the force has to overcome this friction, so to speak, greater than or equal to that force of friction in order to move that object, right? So let's say that so this depends on the uh, coefficient of static friction. So you have to overcome the coefficient of static friction, and then after that there is the coefficient of kinetic friction, and that is for the motion. Okay, and you have to overcome this first before you can move on to the mu k. And so a very simple graph that I'm sure you've seen, it is something like that. So let's say you've got your motion, so you're gonna move boom, and then you reach certain height and then it drops. So you've applied a force, so that's your F A, and that's your FF on the y-axis. So you've applied a force and then you reached a certain point, and then after that point it drops, and so the coefficient of kinetic friction is less than the coefficient of static friction, and so you need less force as time progresses, or the friction decreases as you apply more force. And so also you can interpret this as a time graph. And also, if we talked about an angle, so let's say you've got a box right here, and you've applied a force in this direction, so you're pushing, so let's say there's someone, so pushing a shopping cart or something, or versus if this same object and you're pulling it, which one would require more force? And let's say that the angle theta is the same as both of them. And so for both of these scenarios, so we're asking in which of these scenarios, 1 or 2, do you need less force to move that object? And so if pause the video, figure this out. And so if you figured this out, so just to double check. So here, if you are pushing, let's think about it. So you are pushing at an angle. So you're applying so that's your FG, right? That's your FG, you're not playing with that. And then you've also added another force. So that's your force that is going down because you're pushing. That force that you're applying has an vertical component to it plus an x component to it. Your vertical component is adding to the FG, so it's adding to the weight, which indeed adds to the normal force that is pushing upwards. And so you need much more force to push an object than to pull the object, because if you do the same thing here, so you've got your FG, which is the same, doesn't change in both of them, but this time you are pulling, and so that's your Fn. Your Fn, if you analyzed it, has a vertical component to it. This vertical component adds to your Fn. And so when you add to the Fn, you're not playing with the Fg, but you're adding to the Fn. So there's less force that you have to apply to pull that object and to move it from A to B, let's say. And so that is just a quick overview about pushing and pulling in dynamics and the coefficient of static and kinetic friction. Hope it was helpful. Thank you so much and have a good day.